Hello students, AS level chemistry, chapter is atomic structure, lecture number 2. In this lecture we are going to talk about isotopes. First of all, we will discuss about writing definitions for isotopes, and then we will talk about the properties of isotopes. Now you must remember there are two possible definitions for isotopes. One definition is the general definition and the other definition is in terms of subatomic particles. But whenever you are writing any one of these two definitions, it is important to mention two pieces of information in the definition to score 2 marks. Now if we write on the first general definition, what you can say, what are isotopes? You must start your definition by writing isotopes are atoms of the same element having same atomic number but different mass number. If you have written both these pieces of information, you will score 1 mark for each of these 2 points. So this is one general definition that we commonly write down for isotopes. The second definition that we are going to write down, it is in terms of subatomic particles. Again, you must start your definition by writing isotopes are atoms of the same element having same electrons and protons but different number of neutrons. Again, there are two pieces of information, 1 mark for each piece of information. Now both these definitions are equally acceptable. You can write down any one of the two definitions whenever it is asked. But if ever in the question paper it is clearly mentioned what do you mean by isotopes in terms of subatomic particles, whenever it is clearly mentioned in the question paper what do you mean by isotopes in terms of subatomic particles, it is a must, you must write down second definition, because if as an answer you will give the first definition, the examiner will not give you marks for writing definition number 1 in terms of subatomic particles. So these are the information that you must remember in your mind while answering a question in A levels. You must be careful what is the required information, and according to the required information you are supposed to write down your answer. Okay, this is one thing we have come to know how to define isotope. One is general definition, other is in terms of subatomic particle. Second thing comes, it is about the properties of isotopes. Isotopes, they can have chemical properties as well as they can have physical properties. But if we talk about chemical properties, always remember isotopes, they have same chemical properties. Isotopes, they have same chemical properties. Now why they have same chemical properties? Simple reason that you can remember, isotopes have same chemical properties because they have same number of valence electrons. Even if you write down same number of electrons, even then it is acceptable, no problem. So one thing you have come to know, that isotopes, they have same chemical properties because they have same electrons, and particularly which electrons are involved in the bond formation in chemical properties, valence electron. So you can write down valence electrons as well. Second thing, isotopes, whenever we compare physical properties of isotopes, physical properties of isotopes are always different from each other. Now why the physical properties are different? What reason you can write down as an answer? You can say they have, isotopes have different physical properties because they have different number of neutrons. So this is the simple reason that you can remember. With respect to subatomic particles, you are supposed to write down answer that why chemical properties are same but physical properties are different. Now let's take the example of isotopes of hydrogen, and I will explain it to you how chemical properties are same but physical properties are different for different isotopes of the same element. If we look at hydrogen, you know hydrogen has three common isotopes. One is hydrogen H1, that is known as protium. Other is H2, that is known as deuterium, and the third one is tritium, H3, tritium. First one is also protium, is also known as normal isotope of hydrogen, normal hydrogen. Deuterium is also known as heavy hydrogen, and tritium, it is also known as radioactive isotope or radioactive hydrogen. So since tritium is radioactive, it is decayed with the passage of time, it is unstable, it does not exist commonly. So we can ignore the third isotope of hydrogen. So you can remember, commonly there are two types of isotopes of hydrogen which can exist commonly. The tritium does not exist commonly, so we are ignoring it. So the first isotope is normal hydrogen, the second one is heavy hydrogen. Now based on this, if ever you are asked to react hydrogen, normal hydrogen and heavy hydrogen with oxygen, what you must remember, whenever you will combine both of these isotopes with oxygen, you will get water. And what will be the formula of water that you are supposed to write down? If you are using protium isotope, protium, the normal isotope of hydrogen, its symbol is H. Then what will be the formula of water for protium isotope? It would be H2O. But for heavy isotope of hydrogen, deuterium, the symbol is D. So that is why that water would be having formula D2O. Now you must know the difference between these two types of water. First type of water, H2O, is the normal water. D2O, it is the heavy water. It is the heavy water that is used in nuclear reactors. Okay, now you want to study about their physical properties. I have told you isotopes, they have different physical properties. Now what are the different examples of physical properties? One example you can remember, mass. It is a physical property. Now if you calculate the mass of normal water, its mass is 1 into 2 plus 16. Its mass would be 18. That is low compared to the mass of heavy water. Why? The mass of heavy water, if you calculate, it would be 20. Why? Deuterium is 2 into 2, 4 plus 16, 20. So heavy water, it is having higher mass, and normal water, it is having lower mass. You can see the physical property of both these types of water, it is different. Why it is different? Because they are containing different isotopes of hydrogen. Another thing you can remember, another physical properties for these two types of water, if you want to compare their boiling point, if you just have one beaker containing normal water, other beaker containing heavy water, if you start heating them, which water would be difficult to boil off? Obviously heavy water, since its mass is greater, so it would have greater pull from the center of earth. So that is why it would be difficult to send heavy water molecules against the force of gravity. So that is why the boiling point of heavy water would be high, while the boiling point of normal water would be low, because boiling point depends on mass, and mass is linked with the weight, that is the force by the center of the earth, by the gravity. Okay, you can see that physical properties of isotopes are different. Now I am going to give you an example of a chemical property. You will see isotopes, they behave in a similar way when they involve in a chemical reaction. A very simple example of a chemical reaction, you people know sodium metal, it reacts with water. Sodium metal, when it reacts with water, it produces sodium hydroxide by releasing hydrogen gas. Look at the reaction. If you are given sodium and you mix it with normal water, what you can see, you can see normal water on reaction with sodium, it has produced sodium hydroxide, NaOH plus H2. This is an equation for the reaction of sodium with normal water. When you will mix sodium with heavy water, again the bond between D and O will be broken. Chemically same product you will get in this case. Or the only difference, you can see the symbol of hydrogen that we have used in the first reaction, it is H, and in the second case it is D, deuterium. That's it. Otherwise both these reactions are exactly identical. They are showing us that isotopes, they can behave in a similar fashion because they have same chemical properties. Thank you for watching. Bye bye.